go over pages 115, 116. If you want points, make sure you have it out when you're doing it.
What page? 115 and
115, 116. Recording? Yes, sweet. Alright. I'm going to scoot back here for today. As I can. Huh?
Aaron Jones signed with the Vikings.
So page 115 says the following.
What page?
Page 115, 116, got it up on the board. Says fast food restaurant wants to make sure that the average wait time for people passing through their drive-through is less than 4 minutes. Random sample of 1,000 cars passing through the drive-through produce an average wait time of 3.62 minutes with a standard deviation of 1.02 minutes. Use alpha 0.10. Alright, so null is on page 115. So our null is the weight is equal to 4 minutes. The alternative is the weight is less than 4 minutes. Alright, so a couple things to know. This alpha is 0.10. So something that we could start thinking about too is sometimes if you have an alpha that's given to you, this takes place of the p-value. Okay? And this alpha being 0.10 also means that we would be 90% confident that if we were to redo our...
Hey!
Hello.
Missed you.
Missed you.
What happened?
You got a ski boot on. Ryan, read our tweet. She'll tweet you, right? Oh. What up, man? How you doing?
Well,
Wow.
she said her besides she's gone.
What?
Walked around for 8 hours.
With this?
Yeah.
And then woke up
I don't
and
think I did.
I
We gotta
couldn't.
make sure we do. How was it? Thanks for reminding me. Alright,
You're a snitch.
so that
He's
alpha,
not here, he's a snitch.
have page
Everyone that works at Waterway is a snitch.
page
They
one.
hate everyone.
What did me?
Yeah, you, I pointed at you.
What I do?
Keep your mouth shut on the baseball field, okay? Especially about my business. That's all I gotta say.
Okay, well,
Did someone wake up on the wrong side of the bed?
No,
Ryan, you don't need to be in this AV conversation.
No, the conversation's over. I'm not upset. Everything's okay. Just had to confront him.
Alright, we're on page 115, friends. Alright, let's get away from Waterway and get back to our fast food restaurant. Page 115, everybody. So normal is 4 minutes, or alternative is less than 4 minutes. Again, that alpha, a lot of times we use that alpha to take place of the p-value. It also, the alpha would mean that we are at a 90% confidence interval. Okay, so that kind of is important to know as well. And again, I said that when you have an alpha that's in there, the confidence interval will always be 100% minus that 10% until you get to the really weird statistics classes in the future. But you might not get there. Alright. So things that we know, we have a random sample of 1,000 cars, which is a nice sample. They found that our sample had a mean of 3.62. So that's the sample and the sample standard deviation. The sample is 1.02. Okay. Yeah, we missed you.
Yeah, I know. I don't felt good at all.
Alright, so the reason why we're going to use a t-test on here is that I have the sample standard deviation that we're using, we don't have the overall standard deviation. T-test because sample standard deviation. Alright, so that's basically why it's a t-test. I mean, technically, a z-test could be used, but we're kind of in the middle. Alright, so let's go through all 6 steps. We have our null, our alternative. What are some other things we need to do? We need to figure out the t-value, which is found out the same way as we find the p-value. Same idea. Yay.
Good morning. Good morning.
Alright, so, basically our normal distribution, we could make it look like this, where we have 4, and then 4, 5.02, 6.04, 7.06, 2.98, and what line is that? 1.96, and then the last one would be 0.92, or 0.94, excuse me. Alright, so far we know a few things about this. When we shade this, good to see brother. When we know this, we can make our sample distribution based on this. They're saying 3.62 or shorter. So 3.62 somewhere in here. So this is basically what we're doing, but this is not how Desmos is going to show up for this problem. So when we jump onto Desmos with this,
The roof last night.
I am.
Not you, sir. For the sparks one in here.
No, by a long shot.
Oh, sir. Don't think that about yourself.
I haven't gotten out of high school in
Ha!
38 years.
Ha!
But all oil filters are different sizes, so you need one for each
Alright,
oil.
T distribution. Hey, if we have 1,000 cars, our sample's 1,000, what's my degrees of freedom?
Or you could just
999.
automate.
So this is pretty huge.
I'll tell you, I just twist mine off, use
So it looks like this. We need to figure out what our standard error would be on this case. So our standard error is going to be 1.02 divided by root 1,000. So we need to use decimals on that.
I gotta take this.
So
Well, I'm gonna do it myself.
1.02
What is that?
divided by square root of 1,000.
Oh, yeah, we pull plastic everywhere.
So we have a standard error of
Hanging down
0.03.
sides over everything.
Okay. All right. So if I do this and I go 0.03. So we're talking about a t-value of 0.51. So our t-value is 0.51. This is bigger than this. So remember, the alpha can go in place of the p-value. We didn't have to have it go in place of the p-value, but we did. So that means we don't have to go less than 0.05, we're going less than 0.10. And so is 0.5 bigger or smaller than 0.10? Bigger. That's one bigger. Alright, so we fail to reject the null hypothesis. Okay? This means we didn't find strong evidence against the null. Okay? Now, let's see who was listening yesterday. Friends, if we did not find strong evidence against the null, does that mean the null is true? No, it just means I didn't, what I tested upon with my sample is we did not find strong evidence against it in this case. So that's all it means. Even though it was a random sample used, is there another potential problem in the sampling method? I don't know if we found much of a problem. They did have a random sample. It is at only one site, but let's say this fast food restaurant only exists in one location, like it's mom and pop. They haven't franchised out yet. So there's things, if they said like if McDonald's wanted to do this, and they took a random sample of one particular location, well, we know McDonald's is all around the world. So, but we don't have enough information to know if there would be a red flag, because it might be just an individual restaurant. Alright. So, page 116 says, according to census data, the average age of an adult having their first child is 28.2 years old. Ryan, do you have a comment about that?
I mean, not really.
Okay, good, so we move on. I was
I mean, I'd rather be a little bit older.
nice shot.
I'd rather be a little bit older, but 22 is not that bad.
It's 28.2 because
Oh, 28.2.
Alright, statisticians wonder if this age changed since the census. Sample of 25 Coloradans shows an average first child of 28.6, with standard deviation of 3.8. Okay, first off, the census is the entire United States, right? The average adult having first child is 28.2, so they are basing this on the United States. They took a random sample, which is great. Or it says a sample, didn't even say, they just said they took a sample of 25 Coloradans. Okay, do you think other states want to be lumped into what Colorado's data shows?
Yeah, because states like West Virginia may be younger.
Well, yeah, but, so does Colorado apply to us? Or does Colorado apply to the United States?
Yes.
Like, is the sample of Colorado good enough? No, I mean, if you do want to take a random sample, first off, it doesn't even say random sample. It just says sample, but then I took it of an individual location. But, let's go ahead and mark the problem regardless. So, H not, H alternative. Ooh, that's a good, I like, hang on, so first child, so child is equal to 28.2 years old. Alright, let's see. Statisticians wonder if this age has changed. I like your thought. I think we could two-tail this. Okay, so C is not equal to 28.2. Okay, so we're gonna create this in a two-tail scenario.
Could you do greater if you wanted to? Because
So-
it says in the problem, the average first child age is 28.6 in the same.
Cool, I love that, but here's the thing. Yeah, you could do one tail on a situation, but think about this. When you create your null and your alternative, you're basing this on kind of your observations that you've seen, not as your data collection. So if you're just kind of sitting there going, well, they say 28.2, I think it might be different. I mean, I think you can argue it both ways, because let's say you have a whole bunch of friends that are like 22.
Yeah.
And you're like, I got all my friends that are 22, so I think it's less than that. I think you can argue it both ways.
Okay.
Because you would not necessarily know that you would not have taken your sample of 25 people and figured out 28.6 at that point. Like theoretically, when you create your null and your alternative. Okay? But I love it. So, I mean, it's based on your observation. So somebody might say, I know a whole bunch of people who are way older than that, I know a whole bunch of people who are way younger than that, so it could be two-tail. And then another person would say, well, I have a whole bunch of people I know that are younger than that, or vice versa. So it could go either way, but let's look at this as a two-tail scenario, because I kind of like the thought on that. So we have a sample of 25 people, and our sample mean is 28.6, and our sample standard deviation
Something
is.
bigger.
What did I get you guys?
Nothing in this pocket.
Yeah.
Oh, yeah, okay.
Nothing in this pocket.
And the standard deviation is 3.8.
Bro, I keep thinking today's Wednesday.
Okay,
Hold on, I think that's what I'm
so, let's figure out our standard error. Our standard error, we're gonna go 3.8 divided by square root of 25.
Hey, Joe, are you actually reading? Is this
No.
a bookmark?
No.
3.8
Oh, it's just all the pages.
Is this your book for school?
Yeah.
divided by square root of 25 or 5, so 0.76.
Page 420.
So that's a standard error. So we can draw our normal distribution based on this, or our t-distribution. So 28.2.
Melbourne.
So I have a calculator real quick. 28.2 plus 0.76.
Safety.
Yeah, I know.
2896. Add 0.76 to that.
My Ashford resolution. Should we do this?
28.96 plus 0.76.
Those are in some kids' mouth.
Joe, did you do this?
Somebody participate.
No.
29 point.
Bad boy. You violated
Anybody?
401 recording.
I got you, hold on.
Steve.
28.96 plus 0.76.
Sorry. You really right.
27. What? Yeah.
Why the heck did-
0.7 exactly.
No. I need them for Automata.
30.48.
You can keep the
30.48. Okay, will you subtract 28.2 minus 0.76? 27.44.
It's a cool back.
Do it again, please.
It's like a back.
It is.
6.8. One more time.
What a plan to.
25 point what?
One of these
92.
dudes.
Thank you. All right. So here's where we have to be cautious, because we said it could be two-tail. Because we said it could be two-tail, basically you're at 28.6 in here, which is 0.4 bigger.
Yeah.
And then over here, I'm gonna go 27.8.
I went on Mother's
So-
Day, so it
oh,
was
dude.
all like fun.
What happened here?
And I got
Why
like
did this go away?
20 plates worth.
I was just writing on it.
I thought I was gonna die.
Trying. So we're basically looking at the bar here and the bar here. Do we have an alpha value that's given there?
Where?
Anywhere on the problem? So we know we don't have an alpha. So we're gonna go P is less than 0.10. Why is it not 0.05?
Because we don't have
It's two-tailed.
Yeah, we have it as two-tail situation. So that's what our testing value is. Okay, 0.05 times 2 is 0.10. All right.
How we gonna dead one?
Time for Desmos?
Oh,
All right, let's go. Oh, wait, wrong one here. Desmos. T-distribution, sample size 25, degrees of freedom is? 24. All right. And so what we can do is we can either go to the less than or the greater than.
Holy fuck.
Classic.
We have our 0.76. So if we go to the left, it's negative 0.76. Whoops, I meant to say negative in there. Negative 0.76. All right, so we can either find the other one, or I can just go 0.227 times 2. So we come up with 0.54. Okay, does everyone understand why I did it times 2? Is that-
It's two sides.
Yeah, both sides. So I don't have it shown as both sides, but it is both sides. I mean, I could easily change the thing from 0.76 to infinity as well. So 0.54. Is that what it was? 0.54? 0.45. 0.45. So we're gonna get 0.45 is our p-value. Okay, is this 0.45 bigger than 0.10 or smaller? Huh?
Bigger, fail to reject.
Yeah, so this is bigger than this. So we fail to reject our null. Okay, does that mean that our null is true? No. All this means is, hey, we did not find evidence to support our alternative, so we have to fail to reject. So we're not saying that our null is true, it's just I did not find evidence to support our alternative. So, and again, statisticians will know this difference. Unfortunately, other people will make the wrong decision based on it. Alright, cool. We feel good? Everyone's happy?
Happiest.
Happiest? If you're happy and you know it, clap your hands. Yay.
That's
Skylar
what
was
I'm
waiting
saying,
for other
man.
people to jump in on
No,
this.
I was looking at Liv and seeing if Liv was going to, and then she did.
You knew I.
Yay.
Yeah.
Marcus Mariota
Look at
took
something
Manners,
last night. Oh,
starter.
Not my body, just my face.
Oh.
You looked at my body. And you're
Like,
like,
it was fun.
Let's decide another quarterback.
Alright,
That's
page
all.
46, everybody. Page 46.
Miss you and Marcus Mariota.
Alright. So, this 612, a z-test or t-test for means seeks to find strong evidence that the average of something is less than, greater than, or different than some predicted value. A z-test for proportion seeks to find strong evidence that a percent of something is less than, greater than, or different than some predicted value. The steps for the hypothesis test are given and shown, but highlighted are aspects that are different than one proportion z-test.
Why is
Okay.
this the cover?
So, state the null and the alternative. The hypothesis must be given in terms of population proportion, so 30% or 40% or something like that. Create the null sampling distribution, complete the 7 positions. So the big difference on this is if we are given a percent, you know, so let's say we said we knew that 80% of all people did this or that, that means that this is 0.8. And then in order to find your standard error in this case, and we've only used this equation a handful of billion times.
It'd be 1 by p minus 1 minus.
Yeah. So that's basically how we find our standard error. So we're plugging the 0.8 in our example, it'd be 0.8, 1 minus 0.8 divided by whatever our sample size is. Calculate the p-value. Well, the p-value you're going to figure out using Desmos, that the directions they have on that is using the graphing calculator. State the conclusion, the study in context. So fail to reject or reject. And then check the assumptions for red flags, okay? And then the big thing that we have to do here is we have to go n times p if that's greater than or equal to 10, and then we do n1 minus p is greater than or equal to 10. These have to take place, and that's checking for your normality. Okay? So n is the sample size, and then p is your percent as a decimal.
Truck Nation.
Okay, so on the following page, they say the state of Colorado sets up CO2 meters around the city to try and detect cars that are in violation of emission laws.
Good luck with that.
The goal is simple. We wish for less, more, or we wish for less. I don't know, they have a weird thing. They wish for less more than. They wish for more than 98% of the cars and trucks on the road to be able to pass emission tests. Over the course of 1 week, an auto emissions point is set up at I-225 and I-25. 4,600 cars pass by and 99.4% pass emissions. Use alpha 0.05. So our confidence interval is?
If it's
For Alpha, it's 0.05. 95%. We're 95% confident this will take place. All right. Let's take attendance. I haven't taken attendance yet. Raise your hand if you're not here today.
Nice one, start.
How often does the pendant double?
That's crazy stuff. You should do that to your.
Good, 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 good.
So he's gonna have to wait a whole year.
They would not let you write it.
Not too
Actually,
often.
no, I don't
Away
think
from
that happen in
what?
women's
Away from
basketball.
Well,
Until the fall guy, you have Morgan.
Yeah, Morgan will play good.
Norman could have played, and then you get that.
All right.
And they come out chasing on ice.
the talent gap is.
Back to our story. All right. So, hey, first off, if we're at the intersection of I-225 and I-25 collecting data on emissions, should that be a big enough area to be able to subject it all for everybody in Colorado? Well, no, I don't know about you, but I didn't drive by I-225 and 25 with my car. So that, being that you're just in a specific location, that's a big red flag. Okay? Alpha 0.05. So this is one proportion. We're going less than. Our alternative, our null is greater than 0.98. Our alternative is equal to 0.98. So the reason why we did greater than on the null versus the alternative is we felt that better than 98% of our cars are doing this, or we want this to happen, and then we're saying it's equal to 0.98, so we have one tail situation. They said that the null for the situation is 0.98, standard error, they had already plugged it in and came up with 0.002, so they had used this equation to get to what they'd done, so they did 0.98 times 0.02 divided by 4,600, or divided by square root of 4,600, that's how they get the 0.02. The p-value in this situation, the p-value they came to was this, 1.288 times 10 to the negative 12. And being that they were using an alpha of 0.05, which this is going in place of our p-value, is 1.2 times 10 to the negative 12 a bigger decimal or a smaller decimal? Or is it a bigger number or a smaller number? This is much smaller.
Well, the p-value is much smaller.
They told you, they gave you a p-value, and then we were doing an alpha of this. So we're using the alpha in place of the p-value.
So 1.288 times 10 to the negative 12 is much smaller.
Yeah, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
12, 1.288.
That's teeny tiny.
That's like,
So what do we do?
We're rejecting the null.
Yeah, this is a big time reject the null. Okay? We found strong evidence against.
Do I have to know how many zeros are in
No,
there? Okay.
there's 11 zeros though.
Okay.
Okay, I just made it out because sometimes looking at this scientific notation, meaning we use it like, once in our entire life.
Yeah.
Just to see what it look like.
Use it for chemistry.
Alright, so the p-value is below the alpha. We were directing the null. We find strong evidence that the state of Colorado emissions passing rate is greater than 98%. That's what we just said. Concluded, random sampling is not passed. All cars at one intersection. We did not sample more than 10% of all the vehicles in Denver. Okay, so they are saying that, they're saying right now, this is far less than 10% of cars in Colorado.
But that's a tiny bit. What is it?
Okay? I think that's pretty obvious. I mean, heck, you guys all been parking here, and you all complain how big the parking lot is. Well, imagine there's some other high schools that have just as many cars. So we have far more than 4,600 cars in this state. Or 4,600 is not 10% of the cars in the state. That would mean there's only 46,000 cars in the state, and we know that's wrong. It is impractical and impossible to measure a truly random sample of vehicles. Therefore, the results are encouraging, but we must be aware our sample may not be representative of all vehicles in Denver. Okay? So the thing is, if we're basing Colorado with 4,600 cars at one intersection, this is a big thing. And I tell you, it is amazing how they will kind of throw this in your face saying, look at that, look at that, look at that. And you're like, dude, there's no normality. Like, what do you mean? And then you get in the argument with the person who thinks they know stats and they really don't. Okay. So, my friends, I would like you to please take a fun look at page 119 and 120 for tomorrow. And that's all I got for you. Deal? Alright, we'll start saving my video. 31 minutes of me talking.